There are certain ways of proving that two triangles are congruent. Well, now we're going to talk about different ways you can prove two triangles are similar. We did this first one already in the previous video with the blue triangle and the green triangle. We went through and proved that every side on the big triangle could be multiplied by a scale factor, the same scale factor for each side, to get its corresponding side length on the small triangle. If you can do that with all three sides, if the scale factor never changes, then you have what's known as side-side-side similarity. Now, if you can't show that every side is proportional to its corresponding side, if you can at least show two sides of your first triangle are proportional to their corresponding sides on the other triangle, then you just have to show the angle in between those sides is congruent to its corresponding angle. You'd have side angle side similarity. Now, if those sides were congruent to their corresponding sides, then you'd have side angle side congruence. That's a little more powerful. We are just going to focus on the sides being proportional for the similarity section. If you can show any two pairs of corresponding angles are congruent between the two triangles, you've also shown that those two triangles are similar. It's not necessary to show the third angle in each triangle is also congruent, because once you've shown two of the three are congruent, whatever would be left over, automatically it would be the same in both triangles. So angle-angle similarity is a third way of showing two triangles are similar. Let's look at some examples. So here they give us two triangles that may or may not be similar. They give us a bunch of information about the triangles, and I'm going to mark that information into the diagram to get started. See, I'm seeing a side here, and an angle in between. I'm seeing a side here, and an angle in between. So if we were going to show that these two triangles were indeed similar, I would imagine it would be done using Sas similarity. So let's go in and verify that that is indeed the case. WR would correspond with side KA, so this 10 length would correspond with this 16 length. Then it says RE would correspond with AN. So this 10 length would correspond with this 16 length. Since whatever you're multiplying 10 by the first time to get to 16 would be the same as whatever you're multiplying 10 by to get to 16 here, I think it's safe to say that those sets of corresponding sides are certainly proportional. And since the angle in between them is congruent, we can say, yes, that is enough information to show that the two triangles are similar due to Sas similarity. Very similar example this time. WR and RE, all that's still the same. They're both 10 units long. KA and AN, both are 16 units long. And this time the measure of angle R is similar to the measure of angle N. So is that enough to show the triangles are similar? No, it's not. Because here you could potentially, on this first triangle, have Sas similarity. And on this triangle, you'd have SSA. Well, first of all, no such thing exists. And second of all, it would be different than what you're using on the first triangle. So there's two good reasons to say, nope, this is not enough information to show the two triangles are similar. All right, a little different take on it this time. Here WR is 6, WE is 8, and RE is 7. KA is 9, KN is 12, and AN is 10.5. Is that enough to show the two triangles are similar? So, well, let's see. Side WR would have to correspond with side KA. So let's see what the scale factor is between side WR and side KA. WR over KA would be 6 over 9, which is 2/3 if you reduced or if you simplified it. Now let's pick another pair of corresponding sides and see if when we set up a ratio of them, if we get that same 2/3 simplified answer. If so, then potentially these could be similar triangles. If not, then we can conclusively say they're not similar. So let's see, let's do RE and AN. So RE and AN. RE is 7 versus AN is 10.5. That's like 70 over 105 if you multiply both the top and the bottom by 10. And then if you simplify that, I think 5 goes into both. 5 goes into 70 14 times, and the bottom 21 times, and divide both of those by 7, and there you go, 2/3. I didn't think we were going to get there, but we did. So we just need to prove the remaining set of corresponding sides also would reduce to 2/3 for a ratio. What do we have left? I guess it would be WE and KN. So WE over KN. That would be 8 for WE and 12 for KN. Divide them both by 4 top and bottom. Simplifies to 2/3. So 2/3, 2/3, 2/3. We can say, yes, we can show these are similar due to side, side, side similarity. All right, a person casts a shadow. A tree casts a shadow that is much longer than the person's shadow. We should be able to tell from the given information how tall the tree is. If you care to make a diagram, and I can tell you one thing I'm not in love with on this problem. Let me slide this down. One thing I'm not in love with on this problem is the feet inch that they give you here, and then the flat out inch measurement they give you here, and then they go back to feet inch. Let's just make everything straight up inches so that we are comparing apples to apples throughout this problem. 5 feet is 5 times 12 inches. 5 times 12 is 60. Tack on another 10. Let's just call this 70 inches. 40 is already in straight up inches. This thing, 10 feet, 10 inches. 10 feet is 10 times 12 in inches. So that's 120. Tack on another 10, you got yourself 130. So now we are looking at a more apples-to-apples approach to these measurements. Let's diagram a picture here. We have a person who's 70 inches tall and a 40-inch shadow that the person casts. We have a tree that is probably much taller. I'm going to call it X. And it casts a 130-inch shadow. We can really make a triangle out of this. We can safely assume, because it doesn't say otherwise in this problem, that both human and tree are standing upright, forming a right angle with the ground. And then we can also say, well, the sun has to be affecting the human at some angle that it's also affecting the tree at. So because we have angles that are congruent to their corresponding angles, we have 2 of them in fact, that's enough to justify the claim that these 2 triangles are similar. This is a similarity. And because of that, I can set up a proportion with the side lengths. So the side lengths will be proportional. So 70 on this triangle corresponds with X on the second triangle in the same way that, now let's compare their shadows. 40 on this triangle compares to 130 on the tree triangle. if you cross multiply, 13 times 7, 9100 equals 40x. If you divide by 40, oh boy, who picks these problems? 227.5 inches. Perfectly sufficient answer. It doesn't say to answer in feet and inches, so if someone else wants to do it, make them do the work. Why risk screwing it up, right? But the thing to take out of this section is that there are three main ways of showing two triangles are similar. Once you have proven they're similar, you can use proportions to do all kinds of fun things with their side lengths.